Okay, so I was asked about graphing rational functions, so I thought that I'd just do a quick little demonstration on maybe just trying to help everybody out here. Okay, so let's say that I'm given an equation here, like, I don't know. Let's say we have like let's say we have x plus 2 over x minus 1. So this is a really basic function. So when we're looking at this here, let me just expand the screen a little bit here. So if we're talking about graphing this function here, there's two main asymptotes that we have to consider. One is the vertical asymptote. The vertical asymptote is really created from the restriction in the denominator. Now, sometimes it can look like there's one, but then it ends up getting canceled out because we can factor stuff out. And then in that case, there ends up being a hole at that x value. In this case here, we have x minus 2, so we say that it occurs at x equals 2. Now we also have a horizontal asymptote, and when we have these functions here where we have a linear equation over a linear equation, it's always the ratio of the leading coefficients. So in this case, we have x and x, which is, if there's nothing in front, it's 1. So 1 over 1 means that our horizontal asymptote happens at y equals 1. So if you think about graphing these, what we're going to wind up with here is y equals, oops, 1 second here, just going to try to physically show this, x minus 2 over x plus 2. So notice here how we have those asymptotes here at we have our vertical asymptote at x equals 2 and our horizontal asymptote at y equals 1. Now another question I get from students sometimes, okay, is how do we test these end behaviors? So notice how at our vertical asymptote here at x equals 2, on the left side we're going down, and on the right side here we're going up. So what does that mean? How can we test that to show that that's happening? What we can do is we can pick a value on the left and right side of x equals 2. So if we wanted to do that, I could take 1.9. That's just on the left side of 2. And I could take, on the right side, I could test x equals 2.1. Okay, so if I go to do that here, I'm going to get, oops. So I'm just plugging in 1.9. So that's going to be 3.9 over negative 0.1, which we can solve that through. Gives us negative 39. So what that means here is that on the on the left side of 2, we have negative 39, we're going down. Now on the right side of 2.1, so all we got to, or sorry, on the right side of 2, we picked 2.1 because 2.1 is on the right side of 2. We just want to plug in 2.1 in the same function here. I'll just copy and paste this and change it to 2.1. So, and oops, this doesn't want to calculate for me. Okay, well, I can calculate on my own. 2.1 plus 2 is 4.1, divided by 0.1 is 41, positive 41. So now that means that on the right side here, we're going up. So on the right side of 2, we're going up, and on the left side, we're going down. Now remember that we also have those asymptotes. So that means that we're just going to basically approach the two asymptotes. So sometimes students ask me, how do I know what quadrant we're in? Well, there's a few ways to do that. First off, if you test the end behaviors, you know instantly which way your arrows are going to go on the left side and the right side of the vertical asymptote. So that's one way. And then from there, it can only go in one direction. It just has to approach it goes from the vertical asymptote to the horizontal asymptote, and it can't cross it, right? So That's how you know that, right? Like, so what I mean by that here is, let's say that I have a graph here, like, so let me get rid of this. Just gonna use the free paintbrush tool here. So we set up our X and Y axis, right? And I'm saying, okay, at 2 here, so this is 2. Okay, and that's obviously our X, and that's our Y. We tested our values here. Notice how we had negative 39, which means we have an arrow here. And on the right side of 2, we had 41, which means we have an arrow here. Now, we also know from looking at the function that we have a horizontal asymptote at 1, which would be like, try to get that a little bit more jagged, 1. So that means that this arrow here, this here is also supposed to be an asymptote, so it can only go over here. And this one here, it can only approach over here. Now, what we could do with this one here is we could also find our intercepts and plot them. So, and I'd always recommend doing that. Now, I'm just doing this for a quick demonstration purpose, but this can only go there. If you're talking about what quadrants we're going, which I was asked recently, it would have to go like that. It has no other choice. It has to go from asymptote to asymptote. Hopefully that makes some sense. If you have any more questions about this, please just feel free to ask me in this forum. Maybe what I can do here is let's just create a series of questions. Here, and let's go over those. So let's say that I have like these ones here. I'm just gonna copy and paste all these. Okay, that's good. Okay. So let me just make up random questions here. Okay, so in each of these cases here, let's just identify the horizontal asymptotes and the vertical asymptotes. So in this first case here, we have our horizontal asymptote at, it's the ratio of the leading coefficients. This next one here is going to be the same, so I'll change it. So at the ratio of the leading coefficients, so 2 over 1. So it's at y equals 2. Our vertical asymptote here happens at the restriction here, which is at x equals 3. Okay, for our next one here, we have a horizontal asymptote at y equals the ratio of the leading coefficients, 4. And the vertical asymptote at, in this case here, 4, because it's just the restriction on that denominator, x equals 4. In the next case here, we have a horizontal asymptote at 3 over 1, so at y equals 3, and a vertical asymptote at x equals 1. And then in this case here, we have a horizontal asymptote at y equals 5, and a vertical asymptote at x equals 4. Okay, so maybe I'll just talk about trying to graph one of these here. So the alternative method, if you're talking about what quadrants to put these in, is if you think about this one here, this graph here. Let's say that I want to find my x-intercept. Okay, to find my x-intercept, I'm plugging in 0 in for y. It's always just going to be, in these simple ones, these simple rational equation graphing questions, it's always just going to be the root of the numerator. So in this case here, it would be we're going to, the x-intercept is going to be x equals negative 1 over 2. And the y-intercept, that's just going to be from cutting both these out of the equation, negative 1 over 3. So we're just plugging in 0 for x. Okay, so again, I'm talking about this here. And I'll just grab this here. And then let's go into full paintbrush mode here. Okay, so we're going to graph this here. So let's say that we're talking about what quadrants are we in here. Here's my x axis. Here's my y axis. Okay, now this isn't going to be perfect. This would by no means get you full marks. This is just for demonstration purposes here. Let's say now that we want to graph this. Always do your asymptotes first. So let's grab a new line here. Go red. I don't know exactly how to make it dotted. I don't use paintbrush all that often. Okay, but our horizontal asymptote happens at y equals 2, so let's just put that here. And our vertical asymptote happens at x equals 3, so let's put that here. Okay, so we have at 2. Oops. I didn't mean to put that there, but so this value here is supposed to be 2. And then we have the value at x, the other value here is at x equals 3. Okay. So that gives us our asymptotes. Normally, I'd prefer you to have this a dotted line. I'm just doing this as a quick demonstration. And again, I don't know how to make this dotted. It's probably an easy way. Okay, so then what we could do is we could plot our intercepts. I haven't even created a full scale here, but I'm just going to put little dots there. So we have at x equals -1/2. Let's say that that's about here. That seems a little bit off. Can I move this over here? Let me just fix that up here. Let's say it's actually probably close to here. If that's 3, then a 1/6 of that. Okay. And then we also have y equals -1/3, so that would be about here. So we have those 2 points here. So you said when we make our graph, it has to connect through those like that. And with these rational functions, the other one's going to have to go up through here. So when I go draw this in, again, this is not going to be a very good looking graph. Something that I would not give full marks for on an assignment. Always make sure you put arrows on the ends. Connect it through. Like so. And then conversely, this one here has to be in the opposite. And that's how the quadrants generally work. So that's the other way. So you can test the M behaviors. And in this case, if we want to do that, we're talking about a vertical asymptote that happens at 3. So we'd be testing 2.9. Well, if we did 2.9, that would give us 4.9 plus 1, which is 5.9, divided by -0.1, which would be -59. So for 2.9, which would be here, we'd have -59. That'd be like way down here, right? So we're going down on the left side. And on the right side, we do like 3.1. So if I did 3.1, I'd get +61. Well, that'd be way up here. So on the right side of this vertical asymptote here at 3, we're going up. And then once you have those two end behaviors, you know that they can only go from vertical asymptote to horizontal asymptote, so that's where they have to connect. All right, I hope that this video helped. It wasn't the most structured video in the world, but I just kind of wanted to maybe go over some things for some students that were struggling. All right, thanks.